So now let's talk about how to find the distance between a given point in a three-dimensional coordinate system and a specified axis. Really, when they specify the axis, they're actually giving you the other point that you need to be using to find your distance. It's just a little bit camouflaged and requires a little bit of critical thinking to make sure that you have the second point so that you can then go ahead and find the distance using the formula that we've had. Here we see an example. It says, what is the distance between the point 5, 3, 1 and the z-axis? If you're on the z-axis, both the x and y coordinates of any point on the z-axis will be 0, or else you won't be on the axis. And if we want to figure out the distance between this point and the z-axis, we want to go directly to the z-axis. We don't want to go off at some different angle. We want to go straight to it. The shortest distance between two objects is in a straight line. We've had that discussion before. So to do this, when they say to find the distance between this point and the z-axis, you must know that any point on the z-axis would have an x-coordinate of 0 and a y-coordinate of 0, and we want it to have the same z-coordinate as the given point. If I wanted to find the distance between this point and the y-axis, I'll just go ahead and try to write what the other point would be for all of these. If I'm on the y-axis, both the x and z coordinates would be 0, and I would want the same y coordinate as the given point. And if I wanted the distance to the x-axis, both the y and z coordinates would be 0, and I would want the same x coordinate from my given point. So it's a little bit tricky, but it's just a matter of figuring out what the second point needs to be, and then you just use your distance formula from there. So this particular problem wanted to know the distance between this point and the z-axis, so I made x and y both be 0. I kept the z-coordinate the same, and now I'm going to set up my distance formula to solve. So I have the distance is equal to the square root of the difference of the x's. So I'm going to go 5 minus 0, that quantity squared, plus the difference of the y's. So 3 minus 0, that quantity squared. And then finally, the difference of the z's, 1 minus 1, and that quantity squared. So I will have 5 squared plus 3 squared plus 0 squared, which would give me 25 plus 9 plus 0, which would give me the square root of 34. So there's my exact answer for the distance between this point and the z-axis, square root of 34. If I want that approximated to a certain decimal value, I'll go to my calculator and do that now to round this to about, let's say, 2 decimal places. Okay, going to my calculator to find the distance between this point and the z-axis to the nearest hundredth. I've already figured out the exact answer to be the square root of 34. So now I'm going to go ahead and compute that. And then round the 2 decimal places, looks like I would have 5.83. This 0 would leave this alone as 5.83 units as the distance between this point and the z-axis.